Hi, kumusta? This is Sir Eman, a public school science teacher. For this week, we will learn another interesting lesson in Science 9. Ready ka na ba? Kung ready ka na, tara, simulan na natin. In this video, we will discuss about stars and constellations. Now, this is based on the 18th most essential learning competency, which is show which constellations may be observed at different times of the year using models. Now, before we get to this competency, we will first have these three enabling competencies, which are infer the characteristics of stars based on the characteristics of the sun, infer that the arrangement of stars in a group or constellation does not change, and observe that the position of a constellation changes in the course of the night. Let's begin. Do you have an idea what constellations are? Well, probably you have heard already of the names Capricorn, Sagittarius, Pisces, and the likes. These are actually examples of constellations. So, what then are constellations? Well, constellations are a group of stars that appear to form a pattern or picture in the night sky. So, take note, group of stars. So, before we dig deeper on constellations, let's discuss first what stars are. Well, basically, stars are massive ball of plasma that emits light throughout the universe. So take note, gigantic or enormous ball of plasma. But what then is a plasma? Plasma is actually the fourth state of matter. So aside from your solid, liquid, gas, you have this fourth state, which is plasma. Well, plasma is an ionized gas. Okay, this is an ionized gas where electrons are ripped away from the atoms, and this results to the formation of a superheated gas. So in simple terms, when we speak of plasma, this is a superheated gas. Okay, that's why it's called an ionized gas. Now, having said that star is a massive ball of plasma, is it correct to say that a star is a ball of fire? You will see other references stating that stars are ball of fire. But is that correct? What do you think? Well, the answer is actually no. Why? Because fire is produced by burning material and the presence of oxygen. However, the outer space is a vacuum. There is void of particles or matter. Actually, not really void. There is low density of several atoms or elements, say for instance your hydrogen or helium, but there is no presence of oxygen. So it's impossible to form this fire. Okay? So what is more correct would be star as a ball of plasma or star as a ball of ionized gas. Okay? Did you get that? Hopefully that is clear. Okay? Now I have another question. Are you familiar with the closest star to Earth? What is the closest star to our planet? I want you to take a look at the illustration on the side. You have the planets in the solar system, and the one at the center is, okay, if you've answered the sun, then you are definitely correct. That is the closest planet to the Earth. So we know that is the one that the sun is the one that supplies the planet with the sunlight that it needs to sustain life. Do you have any idea how far the sun is to the Earth? Medyo mahirap itong hulaan, ano? The sun is about 151.1 million kilometers away from the Earth. That's how far the sun is to the planet Earth. Now, to put that into perspective, if we are in San Pablo right now, if we want to go to Pagudpud in Ilocos Norte, that's the topmost part of the Luzon island, that is about 600 kilometers, and it's going to take you about 10 to 11 hours to get there. Now, if you want to travel from Babuyan Islands, the topmost island of the Philippines, to Holosulu, the one in the southernmost part, that's about 1,472 kilometers. And if you want to circumnavigate the Earth from west to east or east to west, that's only about 40,075 kilometers. So that is very small compared with the 151 million kilometers. That is the distance between the Earth and the Sun. Okay. Now, another unit that astronomers use to account for the distances between astronomical objects or celestial bodies would be the unit light year. So light year, it is actually not a measure of time, although there is the presence of the word year, but it's actually a measure of distance. Okay, basically light year pertains to the distance traveled by light in 1 year. Light travels really fast. Okay, that's why that is used as the basis. Okay, now in terms of light year, the distance between the sun and the earth is 1.58 times 10 raised to negative 5 light years. So this is actually very small. That's small in terms of light year, pero that's actually equivalent to 151.1 million kilometers. Yung iba kasing mga astronomical bodies, talagang malalayo yung pagitan nila sa isa't isa. So automatic, kapag 1 light year, that's actually equivalent to 6 trillion miles or about 946 billion kilometers. Okay? Now, how long do you think the sunlight will have to travel from the sun to reach the earth? Meron ba kayong idea? Well, it actually takes about 8.3 minutes only for sunlight to reach the earth. That's how fast light travels. Okay? Now, while there is only one star in our solar system, there are actually billions upon billions of stars throughout our galaxy and exponentially more in the billions of galaxies in the universe. I bet if you are going to look at the sky on a clear night, you wouldn't even be able to count all the stars that you will be able to see. But that is actually just a very small fraction of all the stars which are actually present in the universe. Now, the next question is, are all these stars, these billions of stars, the same? If they're not the same, what makes the difference? But that's the next thing that we will discuss. The characteristics of stars. We will discuss these defining characteristics, which are brightness, color, surface temperature, size, and mass. We will take a look at the characteristics of our own sun in terms of these five mentioned characteristics. So the sun is the brightest star on Earth because it is the closest star to us. Now, this actually talks about the first characteristic of stars, which is brightness. Okay? Now, in terms of brightness, this can actually be described by either what we call luminosity or the absolute brightness or absolute magnitude, and the other one is apparent brightness or apparent magnitude. So, how are these two different? When we speak of luminosity, this refers to the amount of light or energy that a star radiates per second in all directions. Okay? So this can be considered as the true brightness of a star since it depends on the amount of light or energy that the star actually releases. Okay? On the other hand, when we speak of apparent brightness, this is the perceived brightness of a star from an observer. So basically, this is based only on the amount of light or energy that reaches the observer. This is affected by the star's luminosity, the amount of light that it actually receives, and the distance, how far the star is from the observer. Okay, so this is not absolute, but rather affected by these two factors. Okay, so what that actually means is that a star may actually be very luminous, but may appear quite dull because it's too far, while a star may not be that luminous but appear to be very luminous because it's actually close to the observer. So that is in terms of your apparent brightness or apparent magnitude. Okay, now that is actually what happens to the sun. There are actually a lot of much brighter stars, but since this is the closest to our planet, the Earth, that appears to be the brightest. Okay, now aside from being very bright, the sun being the brightest in the planet, our star is considered as a yellow dwarf star. Yes, it is yellow. It appears yellow to the Earth's atmosphere just like the other stars of the same kind, although they are actually white or all colors mixed. Now, this actually tells us the second characteristic of stars, which is color. Okay? Now, a star's color depends on its surface temperature. Okay? Cooler stars tend to be redder in color. Hotter stars have bluer appearance. Okay? And white and yellow are in the mid-range. So stars having temperatures which are not that cool and not that hot, they actually have this white and yellow color. Okay? So the sun has a surface temperature of about 5,778 Kelvin, and this tells us the third characteristic, which is surface temperature. So as mentioned a while ago, color and surface temperature are related because basically what tells the color would be the surface temperature, how hot the star is. Well, Astronomers measure the star's temperature on the Kelvin scale. So this is another scale aside from your Celsius and your Fahrenheit. Okay, the difference is that this Kelvin scale has an absolute zero. Okay, in terms of degrees Celsius, degrees Fahrenheit, di ba meron tayong 0 degrees Celsius, 0 degrees Fahrenheit, but these are not absolute zeros. Kasi meron ka pang mas mababa doon, may negative 10, negative 1, at mas mababa pa ng mga negative values. Ganon din sa Fahrenheit. But in terms of Kelvin, this is an absolute zero kasi yung 0 Kelvin, hindi siya gumagamit ng degrees. Ano? Yung 0 Kelvin, wala nang mas mababa pa doon. Ano? That's actually equivalent to negative 273.15 degrees Celsius. So yun yung ginagamit, yung Kelvin na scale. So coolest stars are approximately 2,500 Kelvin, whereas hottest stars can reach up to 50,000 Kelvin. Now, there are these classes of stars based on the color and surface temperature. You see, yung blue stars, they have temperatures above 30,000 Kelvin. These are the examples. You can have combinations of different colors as well. So, yung blue-white, 10,000 to 30,000 Kelvin. Usually, white around 7,500 to 10,000. Yellow-white, 6,000 to 7,500. Yellow, 5,000 to 6,000. Doon kasama yung ating sun. Orange would be 3,500 to 5,500. And red would be less than 3,500. Examples would be this Betelgeuse and Antares. Okay? Let's proceed. Now, astronomers measure the size of a star given in terms of the sun's radius. So this tells us the next characteristic of stars, which is the size. So basically, what serves as the basis would be the size of the sun. That means that a star with a measure of 1 solar radii would be the same size as our sun. For example, the star Rigel, which is much larger than our sun, measures about 78 solar radii. Okay, so the basis would be the size of our sun. This is a video showing how, the sizes of the different stars in the universe. We have here the different planets. Jupiter, that's how big the sun is. And you'll see the other stars in the universe. Blue-white, you have your Rigel. We have this VY Canis Majoris, the largest known star. Okay, so really, these stars vary in terms of size. Now, for most stars, surface temperature is also related to size. Basically, bigger stars produce more energy, so their surfaces are hotter. These stars tend toward bluish white. Smaller stars produce less energy, their surfaces are less hot, and so they tend to be yellowish or reddish. Okay, so a star size along with its surface temperature will determine its luminosity or how bright the star is going to be. Okay, let's have now the last characteristic, which is the mass. A star's mass is also measured in terms of our own sun, with 1 equal to the size of the sun. For instance, the Rigel, which is about 78 times larger than the sun, that actually has a mass of about 3.5 solar masses. So two stars of the similar size may not necessarily have the same mass, as stars can vary greatly in density. Okay, so it doesn't follow that since stars have the same size, that they would already have the same mass. Ano? So hindi lagi ganun. Now, we actually have here the HR diagram, or Hertzsprung-Russell diagram, which shows the relationship between a star's luminosity and its surface temperature. Okay? So, makikita natin dito, yung mga bluish stars, those super giants, they really are the ones which are luminous, sila yung bright, at mataas din yung temperature. Okay? Yung mga mababa naman yung temperature, yung mga red dwarfs, itong mga red-orange, red giants na yan, hindi sila ganun kaiinit, but since they are large, sabi natin kanya, that's one factor, luminous din sila, maliwanag din sila. Okay? So, Again, so far we were able to discuss already the characteristics of stars, which are brightness, color, surface temperature, size, and mass. So we shall now go back to constellations. As mentioned a while ago, constellations are group of stars that appear to form a pattern or picture in the night sky, like images of animals, objects like wagon, plow, dipper, etc. But take note, sabi nga dito, they appear to form a pattern. Ano, these are just imaginary shapes or images in the night sky. Baka kasi mamaya lumabas kayo, tapos maghanap kayo ng mga images na ipapakita ko sa inyo, sabihin niyo naman, wala, baka niloloko kayo. Ano? So, these are some of the examples. You have here Aquarius, you have Cancer, you have Canis Major, Cassiopeia, Orion, um, this is Scorpius, and you have Ursa Major. Now, in 1929, the International Astronomical Union, or the AIU, officially defined 88 constellations across the sky. So you might be asking, where did they come from? Uh, um, who grouped them? How were they named? Basically, 48 of them were from the Greeks, Babylonians, and possibly even earlier civilizations. And the other 40 were added by European astronomers in the 17th and 18th century. They don't actually look like this. Wala, itong mga ito, ang nandyan lang, itong mga stars na yan. Wala pati yung mga lines na yan. Okay? So, yung mga early people, they're the ones who visualize these different images. Okay, this is actually how they look like. So the early people, they made use of these constellations for navigation to help them travel to different places by sea. Determination of seasons, because there are constellations that only appear on certain seasons, and that is related with agriculture kasi nga pag lumabas na yung mga ganitong constellations, alam nila na panahon na para magtanim o panahon na para mag-ani. And that's also part of their religion with different rituals in form of worship that is included. These different constellations or group of stars. Now today, constellations are useful in assisting astronomers and navigators to locate certain stars and even other celestial bodies or astronomical bodies. Now, constellation can also be defined as rectangular slices or regions of the heavens holding the stars within them. You see here what we call the celestial sphere. Basically, this is an imaginary sphere where these stars are contained. So aside from yung kanina grouping ng mga stars na yon, constellation can actually refer to the region kung saan matatagpuan yung mga constellations na iyon. Ano? So this specific areas with boundaries. Halimbawa, itong Hercules na to, hindi lang yung grouping of stars na nandyan, yung buong area na yan. So nagkakaroon ngayon tuloy nung coordinate system na tumutulong para ma-locate nasan ba yung mga stars na yan. At even aside from those stars kasi na nandyan, yung mismo bumubuo dun sa pattern, meron pa ibang mga stars na nandun. Meron pwedeng nandun din matagpuan sa area na yun, yung mga certain na galaxies or other astronomical objects. So pag sinabi halimbawa na nandun yun sa Hercules, so nandun sa region na yun, sa boundary na yun, dun matatagpuan yung certain na celestial body or astronomical object na yan. Okay? So that's actually very helpful. Now, we have a question here. Are the stars of the same constellation near each other? Magkakalapit ba talaga sila? Magkakatabi ba sila? Well, the answer is actually no. Each constellation is a collection of stars that are distributed in space in 3 dimensions. The stars are all different distances from the Earth. So, ang itsura kasi parang na-imagine natin will be it's only a single plane. Parang papel kung saan doon nakadikit yung mga stars at pantay-pantay sila lang lahat ng layo from us. But actually, that's not the thing. Ano, sabi dyan, they are distributed in space in 3 dimensions. Ano, hindi yan nasa isang plane lang, kundi magkakalayo. Merong malapit, merong malayo, merong bright, merong mas dim kaysa dun sa iba. The stars in a constellation appear to be the same plane because we are viewing them from a distance. Napakalayo kasi natin mula sa kanila. So ito, although it seems as if na sila ay magkakalapit, but actually, they're different distances from each other and from the Earth. Okay? Now, bakit hindi nagbabago, sir, yung arrangement, yung combination itong mga stars na to in a constellation? Well, alam natin, di ba, napakalayo nga nila sa atin. Ano? Now, probably, observe, kapag meron kayo tinitingnan mula sa malayo, kung gumagalaw halimbawa yung mga taong yon, although gumagalaw sila, pero yung increment ng pagbabago sa posisyon nila, napakaliit lang din. Diba? Now, pwedeng tumatakbo sila ng mabilis, pero yung paggalaw nila mabagal. Maliit lang yung space na inaalayo. Now, that's a few kilometers only. But what about in terms of these celestial bodies? These are about millions, billions, trillions of kilometers away from us. So, kahit gumagalaw sila in the same manner that our sun, together with the solar system, is actually moving, circling around the center of the Milky Way galaxy, hindi natin napapansin kasi nga napakalayo nila mula sa atin. Okay? Now, this leads us to another question. Do constellations move over the course of the night? Nagbabago ba? Alam natin, yung ating planeta is rotating on its axis, right? Counterclockwise motion. So basically, it moves from west to east. That's actually the reason why the sun appears to rise in the east and set on the west. Sa umaga, sa east siya nagra-rise at sa west naman siya nagsiset. Now, in the same manner, since the Earth is rotating on its axis in this direction, the stars move in the night sky from east to west. East to west. So, pwedeng yung alas 6, pwedeng alas 6 yung nakikita mo dun sa eastern part. Eventually, bago mag-umaga, it's going to move to the west part of the sky. Okay? And lastly, do we see the same set of stars throughout the year? What do you think? So kanina, kung ang dahilan kung bakit nag-move yung constellation in the night sky is because of the rotation, this time, nagbabago-bago yung set of stars na nakikita natin within the year because of the Earth's revolution around the Sun. So if observed through the year, the constellations shift gradually to the west. This is caused by the Earth's orbit around the Sun. In the summer, viewers are looking in a different direction in space at night than they are during the winter. So, ito yun, di ba, yung ating planeta, although hindi ganito talaga yung shape niya, it revolves around the sun. So, syempre, at June, itong area na to yung makikita niya. Paglipas ng panahon, July, ito ng area na to. So, may ilan pa rin natitira. August, ito ng area na to. September, itong area na to. October, dito naman. So, kaya nagbabago-bago yung set of constellations na nakikita niya. Okay? So, yan. So, during spring, these are the set of constellations na nakikita. During summer, fall, autumn in other countries, and winter, ito naman yung nakikita. Okay? Minsan cloudy, kaya gusto mo nating mag-stargazing, nahihirapan tayo na makita yung mga stars. At kung hindi naman tayo sanay, hindi natin madaling ma-identify yung groupings na yan. Now, to help us identify these different constellations, we can actually take advantage of these applications. Itong Stellarium, which you can download and install in your desktop or computers. This will help you see this different constellation in the night sky. Sa cellphone naman, in iOS devices, those who are using iPhone devices, pwedeng i-download those star map. Okay?